Today's lab is extraction, and then next week we'll be doing crystallization. So extraction is a purification technique based on how well a solute is dissolved in what it's in versus another immiscible liquid. Now remember that the liquids will be immiscible, that is, they won't mix with each other and stay mixed because they have different intermolecular forces. Almost always it's an aqueous or water phase with some organic liquid which is held together only with dispersion forces. And so when you mix the two together, there's no interaction there between the water that's hydrogen bonding and the organic dispersion forces, and so the two liquids will separate. If you have a solute, for instance, in the aqueous phase, but that is slightly nonpolar, it may actually be more soluble in the organic phase, and so when you mix the two up, it will move from the aqueous to the organic phase. That's the whole idea of extraction. Alright, so typically extraction is when you pull what the product that you want out of one layer while leaving the impurities behind, as opposed to pulling the impurities out and leaving the product that you do want in the original layer. That, by the way, is termed a wash. It doesn't really matter whether you're extracting or washing, they work in a similar fashion. Here again, when you mix the two layers, you're bringing new intermolecular forces around which might be more attractive to certain solutes. And so the solutes will move into the new layer as it separates from the old layer up to a point, usually something like between 60 and 80% saturation, depending upon what solvent you're working with and what solute you're working with, and there are equations where you can calculate it out. But for our purposes, let's just talk about generalities. As it turns out, one wash is great, but two smaller washes are even better. Okay? So why? Well, if you take one 25 ml wash of, let's say, 100 mLs of your reaction mixture, you might pull out 80% of the impurities. It's pretty good purification. Okay? Whereas if you do a 15 ml wash, you're only going to pull out 70% of the impurities. But then when you separate out that layer and then put in another fresh 15 mLs, you're going to pull out 70% of the remaining 30%, or as the board says, 91% total of the impurities are gone. Okay? Now, you use slightly more, you use 30 mils instead of 25, but if you used 30 mil wash, you might get 83%, and you're still not up to the 91. You want to probably stop at that point, not do a third or even fourth one, because each time you are taking a small amount of the product that you do want, so it becomes, for a smaller and smaller amount of percentage of what you're pulling out, you keep losing product. So usually 2 washes, 3 at the outside. Some procedural notes. You're going to use 30 mLs of the stock solution. Here again, that's what you're aiming for, but just write down exactly how much you do measure out. That stock solution has 20 grams of benzoic acid and 780 milliliters of toluene, and has had some salicylic acid added to it. That acid is going to act very similar to the benzoic acid through the extraction procedure, and so that's why we're going to recrystallize the product next week. You're going to want to measure 30 mLs of aqueous sodium hydroxide. We're kind of cheating in that we're doing a reaction in addition to the extraction. Benzoic acid is not soluble in water, but once you've taken the sodium hydroxide and neutralized the benzoic acid, you end up with sodium benzoate, and that carboxylate is soluble in water. So as the reaction proceeds, the benzoic acid turns into benzoate and then enters the aqueous environment. So you're going to extract the toluene twice with 15 ml portions. Here again, it doesn't have to be exact. You measure 30 mLs and pour about half of that in your separatory funnel, and go ahead and do the extraction. To do the extraction itself, you put the grease the stopper, put it in, shake it up, then by opening the stopcock, close it, shake some more. Once you feel like you've really shaken the two layers and gotten them mixed together very well, you turn it up, set it in the ring with a cork ring on it to cushion it, and let the two layers separate. You're going to drain the aqueous portion, which should be on the bottom, as water is more dense than toluene. Drain the aqueous portion into a beaker or an Erlenmeyer, and then add the second 15 ml portions, or whatever's left in your graduated, to the separatory funnel. Repeat the extraction. Set it back in its holder. The aqueous layer should be on the bottom. Combine that with what's already in the beaker or Erlenmeyer. Then you're going to add HCl. Okay. Now, what we're doing by this is neutralizing the hydroxide and reprotonating the benzoate. So here again, as the pH approaches 7 and then drops below it, you're going to notice benzoic acid start to precipitate out. You're using 10% sodium hydroxide, 10% HCl, so 30 mLs should by right neutralize all the base and bring it down to pH 10. So you're probably going to need just 40, 45 mLs. You could go up as high as 70 if you need to. Chill to maximize the precipitation. Once it's precipitated, how do you tell that you're getting more? You can't. All you can do is put it in the ice bath and leave it until it's nice and cold. Once it's cold, it's chilled, and any precipitation you're going to get is there. You're going to collect the white benzoic acid via vacuum filtration, which means you need your Buchner. You need a filter paper cut to fit so that it covers all the holes but doesn't go up the side. Otherwise, it doesn't necessarily have to be exactly round. You need your filter flask, that's the one, the Erlenmeyer with the little arm on it, and a filter flask adapter. And you need a vacuum hose hooked to the house vacuum, which are on your desk. Turn the vacuum on, moisten the filter paper with a little bit of distilled water, that's your solvent, and then collect it, the precipitate via vacuum filtration. You're going to dry it in your drawer for a week, and then when we come back, we'll see about cleaning it up and getting rid of that salicylic acid.